Hello, hello, hello. So today we'll be start with generic. So generics is in Rust. Generic is like what I've known till now is just capital T. This capital T is sort of generic for me. That's for what it does. It sort of makes it generic. You can pass any sort of value from that, but that's also variable. So I am not very clear with the concept of generic. So today we'll be starting with generic and we'll see what it is. So the generic is a topic of generalizing types and functionalities to a broader case. Sort of generalizing, but not in a variable way. Variable is also like generalizing the data, but only that. But it is now generalizing the types and functionalities to a broader case. Now, this is extremely useful for reducing code duplication in many ways. In static dispatch, we sort of used this generics. In dynamic dispatch, we used dynamic sort of variable, not static. So no need for using the generics there. But in static dispatch, we did use this generic with capital D. So this is extremely useful for reducing code duplication in many ways, but can call for rather involved syntax. Namely, being generic requires a great care to specify over which type of generic type is actually considered valid. Now, this is simplest and most common use of generic is for type parameters. So type parameters is specified as generic by use of angle brackets, which is this angular brackets, and upper camel case, all right, like AAA, BBB, something like that. But we have only used a single T, so it has been a capital T. I thought that's how we, defined generic. But no, it is in camel case. All right. Now, generic type parameters are represented as this. Usually, that's what you see. But it can also be named as capital A, then small a followed after that, and then B, capital B, and then small b followed after that. So yes, we can use camel case. Now in Rust, generic also describes anything that accepts one or more generic type parameters. Again, this T, I don't want to call it T, I will be calling it generic T. And any type specified as a generic type parameter is generic, and everything else is concrete, which is non-generic. Now, for example, defining a generic function named foo that takes an argument t or generic t of any type. So there is a foo, it takes argument t. Now t is defined as generic type. So yeah, and then we are making some functions out of it, or functionalities out of it. Now, because the T, I don't know which T it's talking about, this one or this one. Because T has been specified as generic type parameters using this R. So this T has been specified as generic type parameters because of this T. So it is considered a generic when used here as args and T. It's not considered a variable, it's considered a generic type. I don't know what the difference between a variable and a generic is. Really, it's like, generic is sort of variable, but it does not contain some sort of value to a number or anything like that. It helps this pass some condition that otherwise would not have been passed because it was only for one type. But now this generic type is defined for like everything. You can pass, I guess, I32, you can pass U32, you can pass, I guess, character, like anything from this generic type. But it should be defined. Then only you can pass anything. Now, this is the case even if this T has previously been defined as a struct. So see, T has been defined as struct. Over here we can see, no, this is not T. Oh, but I don't see any struct of T. But this will be the same case even if the T has been previously defined as a struct. So we can pass a structure that is single, we can pass a structure that is single gen. So this is because of this generic T. I think that's the case. Now this example shows some of the syntax in action. So we'll see some syntax in action. Is there any dramatic output of it? Uh, there is none. So yeah, because there is no print statement and all that. We are just defining, you know, let. So we are just defining certain variables, which is unused. Therefore, we have used these underscore before defining the variable. This. So nice, but we'll see from over here. So there is a struct defined as A. So even if we passed A over here, we have to define this as generic A. That's how we used it. Where do we use this A? I think over here. Yeah, we are using A. But let's see. So a concrete type is A. This is not a generic type. This is a concrete type, which is sort of non-generic type. Over here it's written. It's non-generic, then it's concrete, else it's generic. So any type specified as generic type parameter is generic. Everything else is non-generic, which is concrete. So this is not defined as generic, so it is concrete type. Now the letter says that in defining the type single, which is this, which takes the value of A, and we don't know what the A is. A can be a number, A can be a character. But for now, what we know is A is a structure. Just that. That's all what we know about A. The first use of A is not preceded by this angular A. Therefore, single is a concrete type. Now, this single is a concrete type, and A is defined as above. So A is exactly as defined as above, which is a structure of A. What it's doing, we don't know. But it can be something like structure of B, which can be storing some points or anything like that. No worry about that. But what we are seeing over here is, since there is no angular A over being used before defining A or before using A, so this A we used over here is a sort of concrete type, not a generic type. So here is the single first use of the type A, singles first use of type. So we'll be creating another single gen. Now we, instead of passing A, we pass a generic type T, which can be A, but it is generic. So it can be B, C, D, anything we've defined or we can define later on. We can pass that over here. And why do we know that? Because we have used angular T before that. So angular T and then followed by an argument that is T, which is now generic because we know because of this angular T. So now over here we can pass A. If we later define something like B, we can pass on that. If we later define something C, D, E, we can pass all of that through just one single sort of structure. Otherwise, we would have to create other structures or other sort of functions for that. But now over here, no need for that. Now let's read the comments first. So here the angular T precedes the first use of T. Yeah, exactly. This angular T precedes, yani it comes first before this capital T. So the single gen is a generic type. So single gen case, this structure is a generic type, whereas this single structure is not. And it says it could be anything, including the concrete type A defined at the top. So this T can be anything, including the A defined at top over here. Now we go to the main function and see what's happening. So here there is a variable which is taking the value of the structure, which is single, passed by A. So single is passing a as an argument, and whatever the value comes up is storing over this unused variable s. So single is a concrete and explicitly takes a. We cannot give it a b because this is sort of non-generic type. The single is non-generic type. But if we did something like this, a, then this would become a generic type. So, like as soon as we did it, it will become a generic. Now create a variable unused character of type single gen character. See, we are passing now character. All right, and give it a value of single gen of a. Here, the single gen has a type parameter explicitly specified. So now instead of defining t, sorry, we were defining generic using the t. So now the t can be changed with, let's say here we have changed it with character, and now we can freely pass a character through this structure. If we defined it as I32, we could have freely passed some I32 values. Same for F32, U32, U type, anything. We can freely then sort of pass that value from here, and it will take it, no error whatsoever. So now we are saying over here in this statement is we have an unused character variable which is of type single gen, and the generic type is now character, so it's taking character instead of just defining t. Like you have to define now what t is in this case. So in this case it's a character, and then we are using that structure which is single gen, and we are passing a character. Character is passed using a uh, single quotation marks, single quotation, yeah, single quotation and double quotation. So this is single quotation, and inside that we are passing small a. Yeah. So now this is how we pass a generic type with a value and its type defined. But when we were creating the single gen function or single gen structure, we did not define what sort of type this t will have. But as soon as you use it over here, its character, we can duplicate it, and instead of character we can pass some numbers. Instead of numbers we can pass some values. We can do anything with this. Yeah, over here we are saying that, isn't it? We are passing now a. Now we pass some numbers, which is I32. We pass again a character, and we are storing that in a character I32 and t variable. All right, and this worked without any sort of input, so no dramatic input. And now either I want to see some input or some errors, so let's do it. Print ln. I was gonna write print f, but that would have been wrong. I just want to see the t, not t. First of all, see something like I32, which is a variable. Let's make it L I32 because I32 is a type. So we are seeing some that it cannot be formatted with a default formatter. Either we have to implement it, or I think we can use a debug one, but oh yeah, we can't type question mark, so we have to paste that question mark. It's funny. But we have not defined the flag, define debug something. So over here, I think we have to do something like uh, square brackets, inside that derive, in circular we have to say debug, debug, and that's how we did it. Still nothing, so it says derive. Oh, small d, sorry. Yeah. Shit. So debugs D is capital and derive D is small. Something to keep in mind. Because yesterday only we have read about these attributes, isn't it? We've read about the CFG test, derive debugs, and all that. So what we see is exactly what we did not expect. But yeah, we are seeing this. So it just prints out this in a debug mode, which is single chain, which is a structure now, and it has a value of 6. Good. So I guess we shall move on. Let's see what this link is. Hyperlink structure. We have seen it somewhere, no? Yeah. So it was in third. Listen. So we have seen this. Points, unit, pairs, rectangles. So we have seen this. Yeah. No need to see this again. But it says go to structures again. And as for camel case, we did opened it up. It opens up Wikipedia page and shows us this image. This is a camel case. Camel case sometimes stylized autologically. An autological word expresses a property that is also, possesses. For example, the word is a word. The word English is in English. So the word writable is writable, and the word pentasyllabic has 5 syllables or syllable, whatever. I don't know why I was reading that, but as camel case or camel case, what's different is the C's. See the first C and the first C of the second word, which is camel case again. Also known as camel caps. All right. More formally, as medical caps is a writing format, a practice of writing phrase without space or punctuation and with capitalized words. So the practice has various name and convention, and the earliest known occurrence of the term intercap or the Usenet was in April 1990. Now we don't want to read this. We just want to. So generics first thing is completed. We have 9 more to go, I guess. Yeah. Oh, we were sort of in introduction. We now stepped into the first subtopic, and we still have 9 subtopics. So now functions. Will we see any dramatic outputs first of all? Let's do that. No output. That's not a surprise. Now let's see what's written. So the same set of rules can be applied to a function. A type T becomes generic when preceded by the T, capital T. Again, so the same set of rules can be applied to functions. A type which is generic type, which is capital T, becomes generic when preceded by this angular T. As soon as I see capital T, I think it is generic, but no. This angular T makes the type as generic. Now, using generic functions sometimes require explicitly specifying type parameters. Now, this may be the case if the function is called where the run type is generic, or if compiler doesn't have enough information to infer the necessary type parameters. Now, function call with explicitly specified type parameters looks something like this, where there's a function and the sort of type is defined as A, B, and so on. Now we see the main code where there is a structure A, there is a structure SA, and there is a structure SGen, which is taking a type generic T and then T. So let's see. This is a concrete type A. This is a concrete type S, which is now passing a value of A. No different than just being a concrete type. But this one, the third one, is a SGen, which is of type generic because of this angular bracket, and we are passing T as an argument, which is generic, which is type generic. And now we can pass A, we can pass B, we can pass any characters, we can pass anything that we define later on. Now the following function all takes the ownership of the variable passed into them and immediately go out of the scope, freeing the variable. Again, what frees the variable? So the following function, where is the function? I guess this function or this function. Which function? So we have a function, uh, following function, all takes ownership of the variable. So all of these following function takes the ownership of the variable passed into them and immediately go out of scope. So after taking, the variables ownership, they go out of sort of scope, and this in turn frees the variable. It says after that define a function which is regfn that takes an argument of uh, underscore s of type s, which is this structure. Now this has no t or generic t, so it is not a generic function. We know that. After that, we are defining a define a function of gen spec t that takes an argument of s of type sgen, which is a generic structure. Sgen, it has been explicitly given a type parameter of a, so yeah, we can do that. But because a has not been specified as generic type parameter for gen spec t, it is not a generic. So it is not generic because a is sort of concrete and we have not defined a as a generic type. So all, I think so. 2 minutes. We'll go back and come soon. Yeah. Uses a defined at all, and single gen can also have type parameter implicitly defined. So here we were not defining like here. We are now explicitly defining the type, but over here the Rust compiler automatically implicitly defines it, uses it. That's all. Over here we therefore are sort of directly passing the sgen structure without defining the type. But still, this gen spec t is not a generic function because we should have used some sort of t like here and then passed that t over here. So yeah, this is not generic. Now define a function gen spec i32 that takes an argument of s of type sgen i32, and yeah, we sort of just pass the i32 without defining that it is taking i32 because it is a generic type. So it will automatically or implicitly take or sort of define the type, which is i32. So it has been explicitly given the type parameter i32 where this is explicit. If this is explicit, then how does this, oh yeah, that was explicit. Now this is implicit. We directly define 6. Instead, over here, we are giving it a type, which is underscore s has a type of sgen, which takes i32 only. So if we run gen spec i32 and if we try to pass something else, it will throw an error. We can only pass i32 value inside this. So yes, it has been explicitly given the type parameter i32, which is a specific type. Now, because i32 is not a generic type, this function is also not generic. This is also not generic, but the sgen over here is generic. because it's not only taking the type A, it is also taking I32. But this function overall is not generic. This function is not generic. This function is not generic. Whereas this function and the argument, both of them are not generic because S is a concrete type. Yeah. But Sgen is a generic type. Whereas this function is a concrete type. Sorry for that. Uh, I guess we have read this also. So this is the last function that we define. After that, we go on to main, which is also a function. So not last function, second last function. And it says define a function generic that takes an argument of s, underscores s of type sort of s gen t. Now this is generic t because we are not defining any sort of a or passing the value of I32 or something like that. We're just saying there will be a value of type generic t. Take it over there only. Don't define it. Don't redefine it over here. Now, because the S gen t is preceded by, this t, now this function is generic over t because of this. So we say something like in this generic function, there is a generic type t and the underscore s will be of type sgen, which will take t, but this t is not anything that we have defined, but it is only this generic t that's coming over here. So this is why this function is generic. Like function is generic. Sgen was generic, but function was not because there was no defined sort of value. But over here we have defined t and now it is whole generic. Now for main we are saying something like reg function over here. It takes s which is of type A, so this is whole concrete type. Now gen spec t which takes a generic type parameters, but the function is not generic and this A is concrete, so yeah, that's what you pass. And it says implicitly specified the type parameter A. Yeah, because type is A. We have defined A as structure, so it implicitly takes the type as A. Now gen spec I32, which is again, it is not sort of explicit defined. We have explicitly, it was defined over here where we were saying it will be of type I32 instead of just giving it a value, because sgen was a generic type, so we used it its genericity or whatever it is. So now over here we are passing 6, and it now takes implicitly that yeah, this should be I32 and 6 is I32. This will be a type I32. It will not be U32. It will not be any sort of 32 bytes. It will not be I64. It will be I32 only. I implicitly specify type parameters because of this, isn't it? Now over here we say there's a generic character which we are passing in sgen A. Then inside generic function we are passing the sgen as C. Now what is it? This is now implicitly specifying the type parameter character to this generic function, whereas this is explicitly type parameter character to generic. But oh, oh. So instead of writing function as a function, like this is how we call a function, write its name and then use parentheses. And if there are any values to pass inside those parentheses. But over here, what we are seeing is we are calling the function. We use the parentheses and pass a value, but we also define, because of this two colons, we also define that the value inside the value will be a type character. So that's why we used two colons. What if we used just one? This will give us an error, because now this will define a generic type as character, but we want its, ah, let's go to our terminal. Let's try. compiling it by ourselves. Site rust. Uh-huh. I guess we have something like 11. Yeah, 12. So we'll make it 13.rs. We'll paste it. And we want to see certain errors because we have not used two colons. We have only used single colon. So let's do that. Rust C and what? 13.rs. We see an error. It says expected one of 8 possible tokens, which is these. So it can be, two semicolons, not just one. Sorry, two colons, not semicolons. These are colons. One semicolon, one question mark, parentheses, opening and closing. But it found something like this. So it gave us the same error that we did expect. So let's go to the 9. So it was 33. Now we get a no error. And if we run 13, we still don't get any sort of dramatic output. So this character that we are defining over here is a type that we are passing inside this function's arguments sort of argument. So sgen is an argument for the function generic, but this sgen is also a structure which has which has a value that we have to pass, which is a character a. So how about we make it I32? Can we do that? I don't think so, but we'll try doing it. We get an error. So it says, if you really want I32, what you can do is convert this character using as was a type where we, converted it or sort of aliasing it. But over here, we are converting a character as I32 using the same syntax. So it says, define this, then you can pass this whole value in sgen, which takes a generic type. And now that generic type will be of type I32. Otherwise, you cannot define over here saying that this sgen will take a value of I32 and give it a character. You cannot do that. All right, so I understood you, sir. We'll do exactly how you told us. We'll convert this character A as I32. Simple. Will this work? It works. If we run nothing dramatic, that's all you want. What else can we do with this? Well, I can't think of any sort of idea more. But yeah, I can think of some. Like instead of just passing C, how about just pass a C without any sort of single quotes and all that? What will happen? Ah, so itself says help. A unit structure with similar name exists, but it is A. So A is a structure that we have defined, whereas C is nothing, not even a variable. So what is C? It is confused right now. So it says it tries to help us. Like, are you calling something like A, but you've written C, which is a small? So it's trying to help us, but not really. How about we make it in double quotes? Because strings can be in double quotes. So will it become a type string? Or, ampersand str or something like that? It did. But since it's implicitly defining, we do not know what happens. So how about instead of implicitly defining, implicitly defining, we define it again like this. But instead of I32, we'll say it as a character, but we are not passing a character because we have used double quotes. So will it take it as a string? Then it will throw us an error. If it takes this as a character, it will not throw us any sort of error. Now we shall see what's happening under the hood. Yeah. So it says something like, if you are trying to use character, then just use a single quotation. Don't use double quotation. So it's trying to help us by telling us use this instead of that. And what else? It says sgen is generic type as tuple structure defined here. So sgen is a tuple structure. I don't know. And it says expected a character found a ampersand str. So exactly. So we will do what? We will instead of character, we will say it's ampersand str type. We'll do that. It has been long, days since we have not used ampersand str. Let's use it today. Ah, so it sort of compiles without any error. But instead of ampersand str, what I think is there are multiple things like there are string. Why can't we use that? Why can't we use string? Because it is also a type. So it says we have to, if you want to use string, we can define this character or this string, this str to string sort of. Then it will be converted into string and then it will be passed. But it is for now just ampersand str, not string. So we know that, but we still want to see what is ampersand str, what is string, and all these different types. Oh shit. Because we do not understand it yet. How about just A? Well, now this is a generic sort of live type that we are passing. So it is not no. But instead of passing A, what do we pass? String 36. Static sort of string. static static. What is the error? Says expected. First of all, do not use backticks, use a quotation mark. So that's the first error that I think we are getting. So can we improve that? Go to this backward. Replace this with single quotation mark. Now what it says, error has reduced, but help remove the unnecessary generic, which is a static type, or this generic. Expected 0 lifetime arguments. Function defined here with 0 lifetime parameters because they are not using anything. So yeah. Static was something like lifetime parameters. How about we go like ampersand str? Not ampersand str, but ampersand string static. And then we'll say str. How about this? But we are passing a lifetime of static, so it will be a lifelong, but it is not taking any sort of, or not expecting any sort of lifetime arguments. Will it take it now? It takes it because now that is tied to a string. What it does right now is something, what I understand from this is till this C or this C string sort of lives but now we are passing, something like static. So now this C will live for a lifetime of this program. But if we do not write this, oh, wow. So if we don't do this, just ampersand str, what will happen is C will live for however long it wants, but not exactly for a lifetime. But earlier it was living for a lifetime. All right, I guess we can move on. We shall move on. So implementation. Now this is an implementation. So implementation is similar to a function. Now implementation requires care to remain generic. So there is a struct S. Now this is a concrete type because no angular bracket T has been yet defined, So the struct S is a concrete type. Now there is a structure which is generic value. Now this has a generic T and the argument it is passing is also of type T, of type generic T. So this is a generic type generic val. Now we are implementing sort of, for F32 for generic value and we are implementing S for generic value. Why are we doing it? I don't know. But there is an implementation of generic value where we explicitly specify type parameters. Now IMPL, which is implementation of generic value for now type instead of generic T, we are saying it will be of type F32 and then we'll pass on that value and use it some way. Now specify what it should do with F32. I guess like print something or do something with this F32 if it is of type F32. If it's a type of structure S, then we'll do something. We can define it in this curly brackets. And if it is of type generic T, so the T must precede the type to remain generic. So it must precede the type to remain generic. Otherwise, it will just become an sort of argument like structure T. That's what will become if we do not precede it with a generic type angular bracket T. Now over here, what we are doing, just one dramatic printing output. So let's do that and we'll see the code. So there is a structure value which is of type F64. There is a generic value which is of type generic. So, generic value T, we are using that T generic defined over here. It can be character, it can be F64, it can be I32, anything. We are implementing for value, this value. We are saying function value, which is taking the self, will return ampersand F64, which will go in self.value, which is over here. So that's how we define F64 here. And implementation for generic value is something like same, but over here we are working with ampersand T, which is taking the address of T, whether it's character or anything. It's taking that pointer and giving it to gen.value, the reference of it. All right. It's not mutating, it's not moving, it's taking the reference and then doing this. Now we have a main. We define value and we pass value as 3.0. For y, we define gen value or generic value. We pass 3, which is of type I32. We can do that. Now we are printing both of them. So x dot value and y dot value. And we are getting 3.3, 3,3. So I'll take a break for a few minutes. Hello, hello, hello. So we are back and we were in implementation. All right. And we see, we sort of saw the value that the X had and the Y had. Now, you know, I was sort of in moment where I thought, why did we use X dot value? Instead, we could have used X dot val or something like that. Or val dot val. So why didn't we use this val instead of value? But then I remember that we have implemented sort of a function for gen val and for val. uh, Inside that function we have a value which takes the reference of the self, and which can be anything, but it is taking it by reference because of this ampersand. And then we are returning the value, the returning the reference of that value stored. So instead of typing small val, we have this value dot value, which will give us a return of this, ampersand self dot val. And in generic type, it will give us a type of gen dot val, which is this. All right. So because of this implementation, we can call it using just value instead of, val and gen val. But that's all right. That's good. This is fine. Now, if we think of it, this three, the first one, is because of this x dot val, which is because of this. Now, this is a float point, so we don't see point 0. But now this is I32. We are saying I32, but we should remember the type will remain intact. Even if we see something like 3, the type will definitely remain intact. It is F64, and this can be of type ampersand T, which is I32 for now. Now, I guess we can move on from this implementation. Now, traits. It says, of course, traits, trait S or traits, I don't know, trait S, I think. There's a little bit of space over here. So trait S can be also generic. Here we have defined one such re-implements of the drop trait as a generic method to drop itself and an input. So there's a non-copyable type, which is empty and null. These both are structures. And then there's a trait for double drop, which is taking a generic type T, a trait, a generic over T. So there's a trait which is called double drop, and it is, having a type T, a value of type T, I guess. Or the trait is of type, this trait is generic or its value is generic. I don't know. I think we have defined a trait called double drop, and the trait is T, like generic T. And then inside that, we have defined a double drop function, which takes the self, then it takes whatever the input it's getting, which is, of type T. And what this function does, well, we don't see anything. So, and there is no return value from this trait. So it's just a trait. What it does, define a method or a caller type, which takes an additional single parameter, which is T, and does nothing with it. Yeah, exactly. It does nothing with it. Now we have an implementation of double drop, which is T. Again, I guess the same one for any generic parameters T. So instead of just T, we have any generic. So because of this implementation over here, we get a generic T instead of just T, and a caller U. So we have a caller U, which is also a type generic over here, but it is being used as caller over here. So now what it does, this method takes the ownership of both passed arguments, deallocating both. Oh, I don't, because it is now a return value instead of just, semicolons. So what it returns is a void. It returns nothing. What is this implementation? I don't understand it. Now there's a function main, which is let empty is equals to empty. There's a function null. Sorry, there's a variable null and variable empty, which is taking a structure of empty and null, which we have defined earlier. Then we have empty dot double drop. and it says we are dropping empty again. So double drop and we say null. So instead of type empty, we get type nothing. So now empty or null to do try uncommenting these lines, and we should see some errors. Yeah. So it says it has been moved because of this double drop implementation. Because of this. And if we do this, we should not get any errors because we are not seeing that. We do. Why? So empty dot double drop, inside that we are passing null. Oh, how about, we use some sort of LLM to get a help. So let's get it. Explain this code. Pass the code. It might be helpful a little bit. So it says the Rust trait and ownership example. So this code demonstrates the generic trait and ownership or drop semantic in Rust. So the type is, struct, which is empty and null. So these both are a structure. Now two simple units, unit structure, which has no field, no copyable, non-copyable by default. It has no field, and why it is non-copyable, I don't understand. By default, so we can make it copyable, but by default it is not. All right. Now the trait. So we have defined a trait which is double drop. Exactly. It has a T. It is not generic because we have not defined it over here. Then it says fn double drop self T. What it says is a generic trait that defines double drop, which, so this is a generic trait, not just a trait. It is a generic trait, which takes the ownership of self and additional value of type T. So whatever the type T is, it takes that value too. The underscore means the parameter is intentionally ignored. We do not use it, so we are ignoring it. We know that we can use any sort of variable if we want to, but since we are going to just ignore it, we can use this wildcard. Now the next implementation for the trait is, this was a trait, double drop. Now for that we have an implementation which has T and U. I don't understand this one. This code is something I don't understand. So it says something like implementation of T and U double drop T for U. So there is a function which is double drop self, which takes the T, generic T, and returns nothing because this returns a void type. So it's nothing, or an empty tuple in Rust. Now this implementation double drop T for any unit, any type U. So any type U, this T is a blanket implementation. I don't understand what a blanket implementation is. Now both the type U and the wildcard argument, which is type T, are moved into the function. Exactly. No, not exactly. How is this U sort of moved into this function? I don't see any U. Is it because of self? Is it because of this self that the U is moved into this function? I think so. I guess I'm just guessing right now because this is something new for me. Now, since neither is returned or stored, both are dropped or sort of deallocated when the function ends. So when we were doing this, empty and then double drop and null, what we are doing is essentially taking this empty and then, this null was a generic type T, this empty was a U, and both of them were taken. And then this, implementation sort of returned what? It returned nothing, which is a void type. But what it did was sort of deallocated these structures. So instead of empty is equals to empty, it became empty is equals to nothing, which is a void, or null is equals to nothing, which is a void again. So it sort of dropped or deallocated when the function ends. So it ends over here, and this empty and null gets deallocated. Now the main function, which is this, there is an empty dot drop null in this line, empty is consumed as self and null is consumed as generic type T. That's how I thought it would have been. Empty was U and the null was a generic type T because it has been passed as a value in double drop. Now both values are deallocated after this call. After this call, both values, this empty and null, have been deallocated. What is it? It says why two lines would fail. Uncommenting these cause compiler error because both values were already moved into double drop and it no longer exists. Exactly. So I think we understood what it is. Let's try reading these errors, shall we? So it says use of move value null. So null is now a move value in line 22. It was defined. Move occurs because null has a type null which does not implement the copy trait. So that therefore it has been moved because of this line which is on 25. Exactly. So because this null does not implement a copy trait, that's why it has been moved and it was not taking any sort of reference of it. So therefore it was, yeah, how about we take a reference of it and we'll run it, but before that we should, but since there's no implementation of copying it, I think this will also give us a new error. Let's see. Now the null value is used over here, but it has been moved, so it cannot be used over here. Null has been deallocated. So now what it says, this function t, this parameter takes ownership of the value and it tries to explain it in further detail. How about we do this? We do this. So we should not be getting any sort of errors. But now we will. Let's go. Why? Because instead of passing null, we are passing a reference of null. But we did not get any sort of error. Now if we try to, see null, will we get no errors? Yeah, we get no errors. Damn it. Like, I should be happy, but I am not. Somehow I am not. Now this, because of empty, it gives us an error which says move occurs because of this empty. Now instead of using this empty, how about we just pass on this reference? So instead of dropping this empty after the function ends, it will not drop it. Same for the null. So we still get error. How about we use this LLM again? Hmm. Now explain this. Explain this one. We have just the different thing over here is we are passing it by trying to pass it by reference, but empty, I do not think this has been passed by reference, but the null has been passed by reference, therefore we do not get any sort of errors. But now let's see what it says. It says key difference is this line. Exactly, you've got to it. The main change is using the reference instead of moving the values. What changed is before the original was something like this, moves both the values. Now empty and null were consumed and moved into the function as soon as they were moved into the function. Now they no longer existed after the call. Now with reference borrows the both value. These double drop borrows both the value. So ampersand empty borrows empty, doesn't move it. Ampersand null borrows null, doesn't move it. Both values still exist after the call. But why do we get this error? Why do we get this error? No, it does not work. We see a error. Now it says, oh, says we should not be getting any errors, but we are. We are getting errors. Let's paste that error that we are getting because of this. We shall say something like, but it is, I think I've also confused this LLM. It's giving the method us. This UDS us. Paste it. Let's go. I think I've confused this. Well, it was Claude Haiku. Is it a good model? I don't know. Yeah, I think because this is sort of free. How about using 20V? But it is also sort of very good. Yeah, you're absolutely right. Now it's get it. It gets it now. It says you are absolutely right. I made an error in my explanation. Why did you? Now the reference on the outside doesn't matter. It says this reference does not matter. And the ampersand in the front of entire expression does not prevent the move. Here's why. The method all syntax when you explicitly write this thing empty double drop and ampersand null, Rust still calls the method on empty itself, not on the ampersand empty, which is a reference of empty. The method signature is something like this. So there's a oh so null or the reference of null was passed because it was of type generic T, but u is also of type generic, doesn't this make it generic? I don't think so. Now let's see what it does. Let it cook. Yeah. So the self parameter without an ampersand means it takes the ownership of the receiver. So now empty dot double drop moves empty into the function. The outer ampersand, which is over here, outer ampersand, only borrows the return value. So it sort of borrows the return value of the method, which is just a unit type. Now the ampersand doesn't affect how empty is passed to the method. Oh, so that's why we didn't get to see, the empty. This will give us no output, which is good for us, no errors as well. So why the error occurs? So the compiler correctly identifies the empty is moved into double drop as self. So because of this self, empty has been moved into this double drop and empty no longer exists after the call. Now referencing empty on the line 27 is an error. To fix it, what you can do is you can say derive copy or clone for structure empty or change the trait into ampersand self instead of self. Shall we do that? Instead of self we can take a reference of it and try doing whatever we want to. This will give us no output, but we'll uncomment this. It gives us out. So this suggestion was false. Or was it? Let's see. Yeah, let's see. Now, if we get error, it is only because of this. So I don't think this LLM is in any way helping us. We get error because of this, and the error is method double drop has no incompatible type of trait. Has an incompatible type of trait. So what it says, expected to type parameter u and found ampersand u. Why did it expect u? It should also expect ampersand u, not just u. How about this? It also gives us an error. On line 17, where's the line 17? This is line 17. So it is expecting the u because of self. But I am not expecting that. So please help us. So it says just remove this reference self, first of all. But now we have an ampersand u over here. Any suggestion, sir? No suggestion. Just gives us an error. Let null is equals to null, empty null, moved value moved here. So it is because of this. Now if we don't want to move it, we just pass a reference of it. We should not get any errors. because of this ampersand u. Yeah, no errors. Now if I try to, do this empty, will I get any error? Ah, why? Because we have used ampersand u. Damn it, this worked. This worked. This somehow works. Let's see what this LLM has to say about it. What about this? Huh? What happened? What about this? And then we are passing a new code. Ah, now it works. Here's why. So it identified that it works, and now it's trying to tell us why. Implement ampersand u, not u. So that's why it works. What happens now is it takes the reference of null, which it was taking as a trait t, but instead of taking directly empty, it takes a ampersand of empty because of this ampersand u, So that's what happens right now. Rust automatically coerces the empty into ampersand empty, a reference, and the method is called on a reference of empty, not exactly on empty itself. Now the cell receives the reference of empty, not the own value, and the reference is moved into the function, but empty itself still exists. Now, why the to-do lines now work? It works well because it has been never moved. So these have been never moved. Earlier, it was giving us error. Now it works fine. What happens if we try to print it? It should print fine. Let's try printing it one. Will it print or will we have to use the debug again? print. print exclamation, which is macro. Because of macro, we have to use exclamation. Will it print? This is a null type. Will it print null? Does not. So it requires formatting and all that. So for struct null and all that, what we have to do is say derive debug. We'll not make any spelling mistakes, like derive is small, debug is capital, I guess. Or I guess vice versa. We have to use question mark. We have to copy the question mark. This we cannot write question mark directly, otherwise we'll get a help prompt. What now? Still. How about now? Yeah. So it gives us a null. How about empty now? So instead of writing it for empty again, we'll just copy it. We'll go to new line. We'll paste it. Now we'll try to print empty, which is like using it. npty. We'll try to print it. We'll get an error. So let's ask it, like, how can we derive debug for both of them? Or do we have to use flags everywhere like this? How can I just say the, so many errors. How can I just say the derive debug once for both of them to be used in println? You can't. Oh, so that's what it says. You can't derive debug for both structs with a single derive debug attribute. But you have a few alternatives. What is it? So that's what I did. Derive debug. Operation 2, use a macro. I don't want to. Shit. Now this got complex very suddenly. It also says something like derive debug and any sort of enum Oh, so we create a enum. Inside that we define a struct which is empty and null. Yeah, this is fine. All right. Since this works, we do not need enum for that. Right? That will give us another level of complexity. We should get a null and an empty. That's all we wanted because we want some dramatic effect with printing statements. If it's not there, we'll make some printing statements. Now I think we can move on from traits. Traits is done. Now we are on bounds. How many topics are left? Oh, damn. Still, we have 5 topics, including this. We have six. 1, 2, 3, 4, 5, 6. Exactly, 6 topics. And we have 1 hour to cover it up. So let's do it. Including this, it is 7. So yeah, because this has a subtopic. All right, let's move on. So the bounds. What is bounds? I don't know. Let's see any dramatic output. If it is there, yeah. So in the last one, there is a dramatic output. Now let's see. So when working with a generic, the type parameters often must use trait as a bound to stipulate what functionality a type implements. For example, the following type uses the trait display to print, so it requires t, which is generic, I guess, uh, to be bound with the display. That is, the t must implement the display. So it is not generic, or is it? It is generic. It is generic. So yeah, I think. So define a function printer that takes a generic type t. Yes, see, the t is generic. So wherever I see a capital T, I know it is a generic t. Whether we use it as variable or as a input value, anything, it is always a type generic t. Now define a function printer that takes a generic type t, capital T, which must implement the trait for display. Uh, is this how we define trait for display? I don't think so. We have to use fmt, debug, and all that. Yeah, so over here, I guess we are defining it for display. Debug, ampersand. Is it all? Like, that's all. Is that all? Hmm. All right. Since it says so, this will print a normal T, which cannot be printed using a normal formatter. But now we have implemented its printer. So yeah, it will now print. Now bounding restricts the generic to the types that conforms to the bound. That is, the bounding restricts the generic to type that conforms bounds. And that is something like struct s is defined, which takes the t display as a generic t, and error, there is a vector t does not implement display. This is taking as a vector t, which does not implement the display. And this specialization will fail. This will fail. So there is a let s which takes the value of struct s. Inside that we are passing a vector. We are passing vectors as a macro, and then 1. So this is a vector, just a normal vector, but we are passing it inside this s. So how will it display this? I don't know. So it says another effect of bounding is that generic instances are allowed to access the methods of the trait specified in the bound. For example, these. So we'll read these. This is our dramatic output. Before that, we should see something like this. What is this? Is this it? Yeah, I guess I've seen this. We have opened it. We do not want it. Let's see. Associated function and methods. This is something new. Oh, it is not. Points, rectangles. Yeah, it is not. So yeah, method took us to the module 9, 9.1. This is methods. Exactly. Let's go back to our bounds and see our main function. So we say use a standard FMT debug. So we sort of imported this library, which is standard library, a trait which implements the print marker for this. Exactly. And over here, instead of using the debug print, we are defining our own print and we are using that. That's good. That's good. It has a trait which is, as area. Inside that, we have a function which takes the self and returns F64. How does it calculate an area? Nobody knows. But we have a trait has area. Inside that, we have a method or function which is area, which takes the reference of self and returns F64 directly. Now for rectangle, we have a structure rectangle and a triangle. For rectangle, we say derive debug because we want to print it using question marks like this. For triangle, I don't know why we did not say derive debug, but we said allow dead code, which is like if we do not use it, do not give us a warning. So allow dead code. Yeah, you've seen it sort of yesterday only. And for rectangle, we have a point and height defined, sort of length and height defined, which is of type F64. Same for triangle. Yeah. Length and height. Yeah. Half length into height, I guess. That's the formula for area. Now let's see. So there's a generic print debug, which sort of takes the T as a generic T, which is a reference. And we say inside debug, we print it like this, whatever T we are passing out. Yeah, so for print debug, if we pass the rectangle, if we define rectangle somewhere, so we pass a reference of rectangle. Now instead of creating something like this and saying this and question mark, we can directly say print debug and it will do the same. So this reference of rectangle goes over T and it goes over there. And now there is a reference of rectangle and we are trying to print it using this debug. So it has to be printable. It is printable, so it will print it. As for a normal println, which is our macro, standard macro, we say area is this, and inside this is a standard FMT display. This is not a debug display, and we are passing area, and inside that we are passing a reference of a rectangle. So area was something over here and over here. So what I think what it gives us, so we have defined a trait which was area inside has area, and then for has area we sort of define what this function or what this method does. What it does is takes the self dot length, takes the self dot height, multiplies it, and gives us back. And so what it gives us back is a F64. So we are just printing a number. All right, so we are not printing a rectangle, we are just printing a number which is 12 exactly. But this print debug prints out the length and height of a rectangle. Now how about I'm going to do the same for triangle. So it says something like uncommon these, but we'll do that later on. And I know there will be error because of this we did not define a derived debug for triangle. First, and second of all, the has area is defined for rectangle. If we want to implement it for triangle, we have to say implement for triangle. Rectangle, instead of rectangle we say triangle. Triangle, and cell dot length, cell dot height, we want to multiply it by half or 0.5. 0.5 multiplied with this cell dot length into cell dot height. This should give us a area of triangle. I think so. So we have a has area for triangle, has area for rectangle. Has area just gives out the F64, which is float 64. For rectangular triangle, we have defined it. And since we are using it, we are using the triangle, we are not getting any sort of, what is it, warning. So we will not use that flag of allow dead code. And this print debug can now print this triangle because, derived debug is there. What else? What else? What else? What else? Now has area is a function area. All right, all right. So we defined a sort of function area which goes to the has area as a, taking the reference of t, it goes to the has area structure or implementation or trait. Has area goes over there and does whatever it wants to. And then the return value is f64, which is t dot area. So whatever the t is, which is the reference of has area, we get its area. So this was the method. And whatever the t is, even if it's rectangle, we get this area. If it's triangle, we get this area because of this method. So we can access t dot area. That's what we are returning because there's no semicolon over here. Exactly. So now I think if I uncomment these, I should see some real values instead of any sort of errors. Yeah. So it says error does not implement either debug or has area, but I've already sort of implemented it. So yeah, no errors at all. Good for me. I see triangle has the length 3, height is 4, and area is 6, which is half of the rectangle. Exactly. So if I say AI sort of give an opinion about this code, I'll say, what about this? What sort of opinion does it have? So it says that this is a great example of trait bound in Rust. Here's what's happening. So trait defined, which is has area, and then debug has area, a custom trait requiring an area method. So area is a method, not a function. This is a function, this area is a function, but this area is a method, and we are implementing has area for rectangle. Inside that, we are accessing that area method, and we are giving it some calculation to do so that it will return a really f64 value for rectangle. Same we are doing for triangle, but instead of we are giving it a different formula, and then it's calculating it and giving us back. Now this is good. This is very great, I guess. So has area is a custom trait requiring a area method, and debug over here. This debug is a standard trait via derived debug, enabling the question mark formatting, which is a debug formatting. Because of that, we were able to print debug. We did not use FMT display on all that for implementation of our own display. Otherwise, we would have to use something like implement, FMT standard display for whatever display has area and all that. Then we would have been able to do that. But now we can use our derived debug just by passing it a t, which is of type generic. So we can pass out anything like triangle, rectangle, points, anything. And then it says two generic function with bounds, which is, print area and print debug and area. So these both functions are a generic functions with bound. So I don't know what the bounds is, but it is with a bounds. So T must implement debug. That's what it says. So T must be, implement debug. If it does not, do not use this print debug. And the second, the function area should implement for has area. If it does not has area, it does not implement for has area, it should not print. But if it does, return a value of type f60. Both rectangle and triangle implements both bounds. So they work with both function. Key concept illustrated is single bound, which is T debug, or T has area, restricts which type can be passed. So single bound, which is both for debug and has area, are restricting what can be passed, what types can be passed. It is not total generic, but it is generic in case like if it is implementing for has area, it can use this function area. If it has a implementation of debug, it can use print debug. Otherwise, it cannot. So it is sort of generic in that sort of state. But these generics are with a bound, or sort of are with a limitation. So if you have not defined a debug for that, you cannot print it like this. And if you have not defined a has area for that, you cannot use the area function. So these are generic, but with a bound. So now I understand what a bound is. It is sort of a limiting factor, which is like if you have defined this, then only you can use this generic function. Otherwise, you cannot use it. Use this generic function. Exactly what I wanted to. Now both rectangle and triangle implement both bounds, so they work with both functions. Now the key concept illustrated over here is single bound, which is T debug, and T has area restricts which type can be passed. Access to trait methods like inside area. This has a generic type, but it is has a bound which is has area. So you can call T dot area because the bound guarantees that method exists. All right. Uh, why it guarantees? Because it is bound for has area. If it does not has area, it will not even use this function. If it tries, it does not have this t dot area, so it cannot. So this is a generic trait with a bound. Multiple bounds. So you can combine them with sort of t debug plus has area and all that. So we can use plus to combine them both, which is if it has the t debug and has area, then we can implement both of them together. But to do, it says to do comment. So the comment mentioned over here, the last, the comment mentions a type that implements neither debug or nor has area. Passing it to either function would cause a compile time error. Now, which is one of the Rust's key safety features. Yeah, you could also rewrite these bounds using where clause for readability. So we can use where clause for better readability. We can say if this area has area, it should return where the t is has area. All right. So instead of writing has area over here, we write it after where, and then inside these over here, we write exactly what is written, like t area. So I think this looks better after using where, but this is also better. Like sort of a shorthand, but not exactly, because we understand what is exactly happening over here. So I think this commentary is better. How about we move on, because we've seen some dramatic effects without any errors. So I'm very proud. Now test cases, which is empty bound. So we want a boundation, but there is not any sort of boundation. So it is a bound, but an empty one. So empty bound. Now the consequences of how bound works. Now the consequence of how bound works is that even if the trait does not include any functionality, you could still use it as a bound. Like EQ and copy are example of such traits. I do not see them over here. So EQ and copy are example of such traits. Trait S from the standard library. Oh, so from standard library, there are EQ and S which are same, like has empty bounds to it. So over here, we should see what it's talking about. So there's a structure, cardinal, blue jay, and turkey. Then there are traits like red or blue. Now we have implemented the red for cardinal, blue for blue jay. As for turkey, we did not. I do not understand what sort of example is this. Cardinal, blue jay. So turkey, I know what turkey is. Now these functions are only valid for type which implement these traits. The fact that the traits are empty is irrelevant. So now there is a function red which takes the red trait, generic type trait, and it takes the reference of t. It gives us the return value of static string, which is red, and exactly for blue it gives us a blue. So we have defined red and blue for red and blue respectively, red and blue trait respectively. Now inside main we say cardinal is cardinal, blue jay is blue jay, which is these types. So cardinal is a variable which is of type structure cardinal. Blue jay is blue jay. As for turkey, this variable is not used, so unused variable turkey is of type turkey, and we have not even had an implementation. So therefore, if we try to run it, we'll get an error. All right. So what it expects is red won't work on blue jay, now vice versa. So red will not work for blue jay and blue will not work for cardinal. Good. So cardinal is red, blue jay is blue, turkey is red. So we have to implement turkey. All right. How about we try uncommenting these and seeing some errors? So we get an error. It says red, uh, which is a boundation because red only takes, where is the red? Yeah, red only takes the red, which is only defined for cardinal, not for turkey. So what if we defined it for turkey as well? Can we use and or something like that? But first of all, let's just, use a different line. Turkey, turkey. Ah, it failed. Now it works. Because now there is an implementation for red, which is both red implemented for cardinal. There's a red for turkey, but I want something like red and cardinal both at the same time. So can we use comma and turkey to do the same? Can we do this? And will it give us any sort of error? It gives us an error. Expected one of these possibilities. So we cannot do this, but we can do this. Why? Let's hear it from our commentator, our Mr. AI assistant. So why? And directly a code. Good. So it says something like, this is a restaurant demonstrating trait bound with an empty trait. Here's what's happening. So the concept is, even though red and blue traits do not define any method or functionality, they still serve as a marker that enforce type constraint at a compile time. So the code breakdown is something like, the cardinal and turkey implement red. We did try defining both of them, but I want both of them together. Like if we are implementing something for red and there are multiple things we want to implement, why don't we just use, a comma and then just say implementation? Or is there any keyword like and all that? Oh, it timed out. So you cannot use comma. How about we just give it a space? How about we give it a just space? How about now? Since our AI is not willing to help us, we will force it to help us. Uh, can we use this? Oh, not here. Here. No, the syntax is invalid in Rust. You cannot write something like this. Correct syntax would be, I guess we would have to do two implementations. Well, if we are doing same implementation for two things, why can't we just use it? Or do we have to define a trait for that? I don't know. Ah, This macro rule. I don't want a macro right now because I don't understand macro right now. So it defines a macro red, which takes cardinal and turkey, and for both, we get implementation of red. So it's doing the same thing, but with a bit of a code. How about we just write the same thing? But I've heard somewhere that we do not like writing the same thing for, two things together. It works. I think it works. So let's move on. That's what we do if you don't understand things. There's multiple bounds. So how many topics are left now? Still, there are 5 topics left. Damn. And only half an hour. So I guess these are some short examples. So we'll see them together and we'll move on. So multiple bound for a single type can be applied with a plus. Like normal different types are separated with commas. Multiple bounds. So let me go back, and instead of implementation, how about we use a plus for Turkey? I don't know what this does, but we'll understand it. Turkey. All right. Then we uncomment this. Try running it. It says not a trait. So cardinal is not a trait. Exactly. It is a structure. The red is a trait. Now that trait can be defined for cardinal and Turkey both. How can we? How can we? Let's move on. What can? What else can we do? I don't think anything else. But let's see this code. So there is a standard FMT debug and display. So we have both. We have both sort of debug and display. Now we have a compare prints, which is like trait debug plus display. So we are defining both traits, which is debug and display. We want to compare it with this. We have a trait red, and we can use trait blue at the same time. But we do not want it to use the same time. And then what we do is we say whatever the T. So there are multiple bounds. So there are 2 bounds, debug and display. If it is something outside of this, like it is not debug, neither display, then this sort of trait goes out of bound. So yeah, it does nothing except showing us some errors. Now for debug mode, it sort of shows us T. For display mode, it shows us T, but without any debug form, without using any colon and question mark. And then we have a compare types, which is again only defined for debug. But then there is U, which is defined for debug again. So I don't know what it does. This is something like there are 2 bounds, like debug plus display. But now there are 2 generic types, which is T and U, and T is ampersand T, which is a reference of T, U is the reference of U, which is a reference of U. And then we are printing T and U, T, U as is. Then in main, we say string is words, array is this, vector is this, and we say compare print. So we are calling out this one. So what it does is takes the string, it gives us a display mode where this is a debug and string words, and display, it gives us the words, which is for string, normal. We want, oh sorry, we want output, we want output, we want output, some dramatic one, please be dramatic. Oh shit. Why? Why? Ah, because of this. All right. So I didn't see this line. Sorry. That's why like I thought we have not used this compare type, so why are we getting this output? But I think we have used it for array and vector, both of them with 1, 2, 3. What if one has a 4? What then? And they're both taking it by reference, so it lives out to be well. So vector is this, array is this, and we are printing it out as t and u. Why are we doing it? I don't know, but we are doing it just for sake. We have a backticks because of these debug. Oh, now because of this print statement. All right, but it says that compare prints for array will give us a error. Why? Why will it give us an error? Because array, for that we have not defined a display. That's why. Is that the reason? Oh, first of all, uncomment these. All right. First of all, uncomment this line. Now try running it. We shall see some errors. Yeah. So error is something like the trait standard FMT display is not implemented. So yeah, exactly what we expected. Like array goes over there. For debug, it will print out an array, but for display, well, we do not have an implementation for display in case of array. So it says, you know, define some sort of display, then we can work out with it. So what now? Can we solve this error? Well, we can just comment it out and run it. We have solved it. Yeah, see? But really, can we solve this error? And the second thing that I want to see is instead of passing array and vector like two different things, can we pass array and array? Yeah, we can without any problem. Let's not do that. Ah, let's hear some commentary from a third perspective. So copying this, getting some AI and say sort of asking why a dumb question and pasting out a whole code. Let's go. So it says multiple things that I can't even read now. But let's go. So it says something like, this is a Rust code example demonstrating multiple trait bounds on a generic type. What happens is the multiple bounds on a single type using plus. So multiple bounds on a single type using plus and compare prints t debug plus display requires t to implement both debug and display traits. Now this lets you use both this question mark, which is debug formatting, and a display formatting on the same value. But for array, this display was not defined, so we did not get this display formatting for that. Now multiple generic parameters with individual bound, which is like using a comma. Now compare types, which is t, which is debug, and u, which is again debug, has two separate generic types, each requiring a debug over here. Now this is more flexible because T and U do not need to be of same type, just both debuggable. Right. Now why this matters? Because both specifying trait bounds, you're telling this compiler, I need this generic type to support these specific capabilities. This ensures your code compiles only if the type can actually do what you're asking. In this example, compare print array would fail because array does not implement display and only implements debug. To do, well, uncommenting it to see the error. That's why the comment suggests uncommenting this to see the error. So we've seen the error, we cannot do anything with it. So let's move on. We can well define a display for that, but we do not have that much time. Only 30 minutes left or less than that. And we have to, cover up three more. Well, including this, we have a fourth. Whereas net, we have a three more topics left remaining. There are also subtopics. Shit. So, oh shit. If we cannot cover it for now, we'll do it, I guess, yes, tomorrow. It says where the clauses. So now there is where clauses. I've seen this implementation because of this AI. So it said use where clauses to, make it more pretty. Exactly like this. Where, and then inside that define a function. Uh, this can still be used over here, implementation and all that. But for now, we are using it over here. No problem. So a bound can be expressed using a where clause immediately before opening this curly brackets rather than the types first mentioned, like mentioning it over here, over here. Additionally, where clauses can apply bounds to arbitrary types rather than just type parameters. Like some cases that a where clause is useful is when specifying generic types and a bound separately is cleaner. What does that mean? When specifying generic type and a bound separately is clear. So we have a multiple bound which is trait B, C for A. As for D, we have a trait E, F, and then we have a my trait A, D for your type. Now, if we used where, we could have written all of these after this. So yeah, we just write A and D, and for my trait, for your type, instead of just opening up the bracket and start the implementation, we say where the A is trait B plus C, which is this foundation. D is trait E and F, and then we start the implementation, and this looks, well, a bit pretty. That's all. We can still understand this because A and D has to be sort of mentioned before my trait. So we have mentioned A and D, but what is A and D is defined over here instead of just in that same line. All right. So when using the where clause is more expressive than using a normal syntax, the implementation in this example cannot be directly expressed without a where clause. All right. Well, it can be expressed without a where clause, but it will become something like this, which is not very, intuitive to follow. Now we again say FMT debug. Oh, so instead of, saying derive debug, we can directly say FMT debug and just use that debug from there. Interesting, interesting. Now we have a trait which is print in option, which has a method which is print in option, which takes the reference of self, not reference, directly self. Now, because we would otherwise have to express this as t debug or use another method to indirectly approach, this requires a where clause. So we have an implementation of t. We say print an option, which is a trait for t or t, this generic type t, where this option t, now we are using option t. If this option is debug, then we do this. Otherwise, well, do not do this. We want this option t debug as our bound because this is what's being printed. Doing otherwise would be using the wrong bound. And then we implement for print in option method, we implement the implementation which is print ln and then use this debug question mark and all that. And whatever the t is, so we say some value of self. The t is sort of self, so we say some self. And in main we sort of apply it. So we have a vector which is a vector 1 2 3. We say vector dot print in option. So we say vector and then print in option, which is directly using this method and which applies this implementation for that. or this generic type, whatever, but this is vector for now. All right, this will just print it out. Exactly. Why sum? Because sum is, to uncover whatever this. So option is sort of a bracket. If option is debugged, then do this. But if option is sum, and to take the value out of this this t, we have to use sum, and then whatever the value is inside that sum, use it. And if you want to pass some errors, we can use error, and whatever the value of pass is, or whatever the value of error is, we can use that. Okay, and error. You've seen that. Let's move on. New type idiom. This can be run. There is a structure of years. Then we are saying year is 42. All right. Year is primitive, which is I64. Now year dot zero, which is tuple. Years dot zero, tuple. Then let years with capital Y. We're passing years as primitive 2, which is years directly. We are destructuring years into this variable. Why are we using such long variables? I do not know. So let's see this to understand what's happening right now. Give me 2 minutes. All right. So now again the type idiom. So the new type idiom gives compile time guarantee that the right type of value is supplied to a program. For example, an age verification function that checks the age in years must be given a value of type years. So there is a structure year which takes I64, no F64, no U64, I64. Then there are days which again is taking I64 as an input. Now we implement years. So years we are implementing a public function which is 2 days. So we are converting, if there is a implementation of years, so what we are doing inside this implementation is converting the years to days. How are we doing it? Using a function that is called 2days, which takes a reference of self, which is years. And it returns us a value of days. So the return is of type days, which is this structure. And what we do is self.0, whatever the self.0 means year is, we multiply those years by 365, we get a days. Exactly. Now for days, we implement something like from days to year. So we create a public function calling to year. We take the number of days and we return a type which is years, and we just take the days which is self.0. We divide it by 365 and we get the years. Yeah. So we have implementation for days, we have implementation for years, And that's what we're doing. Now it says something like, you know, there is a function which is called is adult, and then age, we are passing age, which is sort of a reference of type years, which returns a boolean. So if it is greater than or equal to 10, age dot zero, or the value of age, we say sort of true, else it returns false. Why does it return? Sort of, it is 18, not 10. All right, it's 18. And it's not using semicolon, that's why it's a return value by default in Rust. So now it says let main, and then inside that we have an age, which is year 25. So age has a structure, year 25. Then age days, which is like we are using 2 days. Age is a year, so we are saying age, which is year type. And we have a method or implementation for years, which is 2 days. So we use 2 days to convert that year into days. Then we are printing both of them, I guess. Now, what we are printing is adults, and then we are giving it as age, and then age days, which is this variable, and then we are converting that days variable to year again, and we are giving back to this it is adult because it can only take years, not days. So it will give us a normal sort of output, which is true, true, exactly. Now this will not work. Why? Because what we are doing over here is we are giving the is adult something like days, but instead we should give it something like years. If we try giving it something like days, it will not take it because it is bound by years. So it gives us an error. It says what it says. It says mismatched type. So this argument's expected ampersand years, but found something like ampersand days, which is not acceptable. All right. So because of line 27, which is this, the line 18 function did not work. Now uncomment the last print statement to observe the types applied must be years. Yeah, we knew it, but after seeing this, we obviously know it better. That we cannot just supply a days where it should be supplied with years. Now to obtain the new types value as a base type, you may use tuple or destructuring syntax like this. So there's a year which is type I64. Now years is 42. Years as primitive one is sort of type I64, which is year.0, which is now a tuple. And then years as a primitive 2, which is just years, which is now destructuring. So there are two things that we did. First of all, we just extracted the value from the tuple, which is 42, which was 42. And then we destructured the whole damn years, and we sort of got 42. How about, we implement print for all of them. So we say print ln, because of it is a macro, we use exclamation mark. Then we go and create some curly brackets because inside those curly brackets we use debug. I guess so, because there's no implementation for printing normally. As for debug, well, we have not defined that debug, so I think we'll have to define debug for years. Then what we are giving it is directly years, first of all. It prints it, or does it? It says years cannot be formatted using because it does not. Exactly what I expected. We have to say derive debug in square brackets. So we say derive, then we say debug. Debug. I think this would work now. It works. Now let's use a semicolon and print this. Sorry, copy this whole thing, and we'll try printing everything like years as primitive 1. All right, this is the whole damn name. Shit, I do not want to write this whole variable name because it's so long. Let's just copy it and paste it over here. We get exactly what we wanted. Let's try printing it. So we get first of all years, which is 42. We are destructuring years over here, so we are also getting years 42. But over here we are sort of using dot zero, which is sort of getting the first element from this tuple, which is 42. If we try getting a second element from this tuple or one, we get I guess nothing or some errors. Yeah, it says available field is only zero, and there is no available field for I guess one. How about we say year and then we define something like 56, but then we have to say it is of tuple I64, which is again I64, like two values. Now what? Now there's more errors than just one. So now it also says expected two variables, but I only want to see if this is exactly as we expected. Exactly. And to destructure this year, what we have to do is sort of give it a and B so that we can store the value of years destructuring. Let's see the error. Then we'll decide. It says add something like this. This wildcard. It says what did I do? I just want to destructure this years, which has two values. How about I say something like A and B? But this is a variable, all right, so it's not like how about we directly ask the AI, can we do this or not? Or just improve this, IMPROVE, this, whatever this is, just improve it. Huh? Why did we send it to improve it? This is what we want to improve. I think we should say something like improve this, IMPROVE, this. I guess there is some error. Let's reload this page. Shit. Since I reloaded it, let's move on. But if anyone can think of the solution, well, just give it to me. Either mail it to me, write it down in comments, anything. Just give it to me. Associated items. So associated items refers to a set of rules pertaining to items S of various types. So it is an extension of traits generic and allows traits to internally define new items. So one such items is called associated types, providing simpler usage patterns when the trait is generic over its container types. And it says see also RFCs. Well, we will see RFCs, but not now, I guess. Where is this RFC? Oh, it isn't GitHub. Oh, damn. So this is RFC. RFC extends trait associated. If you want to read this, well, follow this link along and you will get this. We'll read it there. All right. Let's move back. So associated items, we know that. And let me take a break for a few minutes because something's happening with my battery. Yeah, so it's working. Leave a charge and associated items. So you're there. Press move on. Associated items. We have the problem and the associated types. Then the phantom type parameters. The problems. So a trait that is a generic or that is generic over its container types has type specification requirements. User of the traits must specify all of its generic type. In the example below, the contain trait also, sorry, in the example below, the contains trait allows the uses of the generic type A and B. The trait is then implemented for container type specifying I32 for A and B so that it can be used with function difference. Because the contain is generic, we are forced to explicitly state all of the generic types for function difference. In practice, we want a way to express that A and B are determined by input C. As you will see in the next section, associated function provides exactly that capability. All right, so we'll see. Oh, our drama is here. So we have multiple print statements. Let's first of all, you know, our dramatic print. All right, now let's see what this code does. So first of all, we have a structure container. It takes I32 and I32. Now we have a trait contains A and B. So a trait which checks if two items are stored inside a container also retrieves first or last values. So there is a trait contain A and B. Now the function contains, there's a function which is contains taking a reference of self, and then there is a underscore, just taking a reference of A, as we do not want to use it, so it's just underscore. And then there is underscore which is just taking a type of B. It says boolean is the return type, so it returns boolean, explicitly requires A and B. All right, so this explicitly requires A and B, not just the self. That's why we did this. Now this function first, which takes the self, just returns I32. As for, implementation of this, it is over here. All right. So this is just a trait. We are defining methods, which is contain, first, and last. And it says doesn't explicitly requires A or B. Same with the last. Now we have implementation for the contains. The implementation of contains is for containers. What? So this is contain. This is container. All right. All right. So implementation for contain, which is A and B, for container, which is this container structure. Now true if the numbers stored are equal. So if contain and the number 1 and number 2 are equal, it will return that it is true. So self.0 is equals to number 1 and self.1 is equals to number 2. So I think what I understand is correct. So we first of all, make a container which contains two values, let's say 2 and 3. And then we use a contain method which checks whether this container has the value 2 or 3. So we pass two values, either let's say 2 or 5. So if number 1 is 2, it'll pass like, yeah, it's 2, so it's equal to self.0, which is 2, that is stored in the container. But self.1, which is 3 in the container, but we have passed 5, so this is not equal to. So ampersand, which is like true and false, will return false. So this will return false. But if we send 2 and 3 and our container also has 2 and 3, this will return a true. So if this returns a true, we get a true, everything works fine. And our contain method tells us that, yeah, 2 and 3 is contained in the containers. So yeah, now the first is like grab the first number and just show it. So we are just grabbing the first number from the container and just returning that. We are grabbing the second number and we are giving it that too. Now C contains A, B. Where's the C? Where is the C? I don't see a C. It is over here. So in the difference, C contains A and B. In light of that, having express A and B again is a nuisance. So there's a difference A and B and C. A container is a reference to C, which returns I32, where C contains A and B. So just taking this A and B, it's telling us that this is nuisance, but I don't know. We do not give it A and B over here. How can it take A and B for this? Then we say container.last minus container.first. So whatever the container.last is, which is this. And how do we know container.last is a method? Because over here, for container, we have implementation for last. So it returns self.1. So we get self.1. For container first, we get self.0, we get self.0. We subtract them. We get the difference. We return the difference because there is no semicolon. So this value is getting returned. Now in main, we just implement it. So there is a number 1, which is 3, number 2, which is 10. Now container contains number 1 and number 2, which is 3 and 10. Now print is something like does container contains, number 1 and number 2. Ampersand, we are sending the reference of number 1 and number 2. And then over here, we are passing number 1 and number 2. And then we want to check whether it does. So we want a true or false statement over here. So we say container.contains number 1 and number 2 is passed to container.contains. It goes over here. It says container for contains. Then it tries to equate it. And since we are passing the same damn number in container.contains, so it says true. So we get a true over here. Now we are printing the first number, which is container.first. We are printing the last number, which is container.last. We are printing the difference between them, and we are passing out the whole container to it, which is the whole container type, which is this. All right. So yeah, this output is expected. What about instead of sending number 2 or reference of number 2? And why are we first of all sending a reference of number 2? Like, since it is a number, we can just send a number 2. We do not want to send a reference of it. Can't it work that way? This will give us a false. I think it should. Well, it gave us an error. It says expected a ampersand I32. So let's give it a ampersand I32. How about this? Ampersand of 3. What about now? So it says it is false because we are passing this. And how about, oh, we are using ampersand, but I32 is something that we can copy without taking the reference. So I think why we are not copying is because copying is memory intensive, and if there are multiple numbers and all that, it will become a very memory intensive program. So we are just taking a reference, which is not allocating much anything. It's just using pointers. That's why we are not copying. But pointers is heavy than numbers, no? I don't know. I'm not that expert right now. But I think for numbers, we can just copy them if possible. And in this case, it is. Why am I not doing it? Let's move on. So associated types. All right. Now this is the last subtopic. I guess so, or I hope so. Yeah. Then we have a phantom type parameters and last one. So the associated types. The use of associated types improve the overall readability of code by moving inner type locally. So into a trait as output type. Again. So the use of associated types improves the overall readability of code by moving the inner type locally into a trait as output types. Now syntax for the trait definition is as follows. So there is a and B are defined in the trait via the type keyword. Note that the type in this context is different from type when used for aliases. The trait contains type A, type B. Then there's a updated syntax to refer to these new types generically. Then we have function contains, which is reference of self. Then it's taking the value of A from this A. It's taking the value of B, and then it returns Boolean. This is just a trait, so no need to worry about it. We can implement it and do something with it. But what we are trying to achieve from this? Shall we read this again? I guess. The use of associated type improves the overall readability of the code by moving inner types locally. So these are the inner types, and we are moving it locally over here into trait as output types. And this is, I guess, output types. I don't know. Now the syntax for the trait definition is as follows. So syntax for the trait is as follows, where we are using the types internally only, locally. So A and B are defined in the trait via type keyword. Yeah, exactly. And note, we are noting it, that type in this context is different from the type when used for aliasing. All right. So we have used type for aliases. All right. But this is not that type. This is a different type. So we are doing the same thing. We are returning a Boolean if we want to. Then note that a function that uses the trait contains are no longer required to express A or B at all. Yeah. So what? So without using associated types, it would look something like this. Like difference A, B, C, and container is the reference of C, and then I32 is getting returned where the C contains A and B. This is like explicitly saying it like without associating. Whereas this one, which is associating it, we are not saying explicitly like C contains A and B. It is sort of understood automatically because the containers contain something like this. It already takes it. Then the return value, how will this return value be returned? We'll do some operations over here in this curly brackets. All right, let's see the whole function, and our drama is here. So we'll see that too. So there is a structure which is container, I32, then there's a trait which is contains, then there's a type A, type B, then there's a function contains, which is self, again the same thing. First, which is same thing, last, same thing, But what is something we have to remember? It's not in an implementation block. It is directly inside the trait. All right. Before that, we had the same thing, like contain first and last. We were taking A and B by reference, but we did not use type A, type B. We used A and B by reference, and this is reference of self, self. Over here, it's different. Uh, Over here, it's self, self, self. But for A and B, we have ampersand self A, ampersand self B. And for implementation, we are directly saying A is I32, B is I32. We're directly saying that. We do not have to pass all these over here. Now that is interesting. If we can get it side by side, how about I just open it up side by side, right? So this was the earlier one. Let's see the next one, which is this associated types. Now we can compare. This is structure container I32, I32 for both of them. We have a trait contains, and first change that we notice is we are not passing A and B. All right, in contains we are not passing A and B. Inside contains we are saying type A and type B, and then we are using contains first and last as method, same as we did over here. And then for implementation contains, and then we are again not passing it is of type I32, I32 because this contain does not has A or B. So it is not of type I32, I32. Whereas container is. So we are sort of taking contains for containers. So it is sort of implicitly taking this type A and type B for containers, I guess. Now type A, we are again defining is I32. Type B, we are again defining it as I32, which is for the implementation part. And now our contains first and last remains the same. All right, it is the same, exactly same, like no change at all. It's just passing A and B from here, like I32, I32. We are just saying type A, type B, which is of type I32. That's all. And then there's a difference. Now again, we are not passing A, B, C as we do here. In this difference, we are directly saying there is a C, this sort of contains, and then we are passing container and the reference of C, and it returns I32. Why? Because container not last. Again, same thing, but we are not defining A and B, which is like C contains A and B. C directly contains, and contains has A and B type, contains has type A and B. Contains has type A and B in implementation too. So wherever you want to take it from, container dot last, then minus container dot first, and we are getting the same result, I think. So no drama at all, I guess. Yeah, exactly the same. But instead of defining A and B everywhere, we just said type A, type B, and that's it. That's what we did. And this is something associated types, and this is problem. So this was the problem. This is solved by this associated types. Let's read this. Let's first of all close this. We have compared it. Let's read this with all the comments, including all the comments. So a trait which checks two items are stored inside the container also retrieves first or last values. All right. And then define a generic type here, which method will be available to utilize. So method will be contain first and last. Over here, we say specify type A and B are of type I32, I32. If the input types is container I32, I32, the output types are determined as I32, I32, obviously. Now, again, self A and self V are also valid over here as previous one did. Grab the first number, we are grabbing the first number. Grab the last number, we are grabbing the last number. We are subtracting it, we are getting our output. Same. Just the writing style of the implementation and traits is different. We are not defining A and B over here. We are not defining I32, I32 over here. That's the difference. Just that. We are just using type A, which is of type I32. Over here, we are not even defining it is of type I32 because it is not defined for container. It is just a contain. It's just a trait, which is now defined for container over here, like implementation of contain for containers. So shall we move on? I guess we can. Now we have a phantom type parameters. After that, we have a last topic and we can end this. Then we'll have a scoping rule, which is well shorter than this. Oh, not shorter than this because there are subtopics. Damn. Ah, and this cannot be done or completed in one go. So we'll have to, figure out some way. We can do something like till borrowing, and then for lifetimes we have to use a different day altogether, like day after tomorrow. Shit. After 15, we have 16, which is traits. Again, a long giant one, but no subtopics, so good for us. Then macro level, a short one. Error handling, again subtopics. Yeah, this is also a 2 to 3 days, something like that. So it'll stretch out more than a week. We'll have to go for more than a week. This is not something we can finish it in just a week. RC and ARC, I'm very interested about these. I'm very interested about these because they are related to threads and all that. File input and output, open, create, read lines, child processes. This should take some time. This will take some time. And this is short. This is short. Very short actually. And this is also very short. Not at all. So nearly about a week or two, then we'll finish this Rust by examples. And we have also not, started out with our day 9. So we have to do it someday. Let's see if we can start it today only. Now there's a phantom type parameter. A phantom type parameter is one that doesn't show up at runtime, but is checked statically. Okay, not statistically. Sorry, I am my wrong. Not dynamically, but statically. All right, but is checked statically and only at compile time. So if there is any error, we get it compile time, no runtime errors, anything like that. So I think what I have learned till now is compile time error is better than a runtime error. So everything that is compile time and can give us a run sort of error is better, 100 times better than a runtime error, because then we can just return from that, or we can just say this error. We can't, sort it out while just making the code. That's why we do something like error handling, isn't it? Use something like question mark and all that. Now data types can be use extra generic types parameter to act as a marker or to perform type checking at compile time. Now these extra parameters hold no storage value and have no runtime behavior. In the following example, we combine the standard marker phantom data. I don't know what that is, but it is a standard library, I guess, with a phantom type parameter concept to create tuple containing different data types. So first of all, import the marker phantom data from standard library. Then we say derive partial EQ, which is partial equality or whatever. So the phantom tuple structure, which is a generic over A with hidden parameter B, and we have a flag which is partial EQ, which is like allows equality test for this type. Okay. Now there is a structure which is phantom tuple, not phantom data type, but phantom tuple, which has a and B. Now A is A, but B is sort of phantom data. All right, phantom data B is used over here. Then we have again partial EQ for phantom struct, and we are again have first A, then a phantom of phantom data B. Comment says that a phantom type struct which is a generic over A with a hidden parameter B, like same thing, but just the name is different for the structure, which is phantom struct. This is phantom tuple. Now, what will be the difference is something very crucial that we should know about. For now, we don't. It says allow equality test for this type. I don't know what this type is right now. Note, the storage is allocated for generic type A, but not for B. Why? I don't know. Therefore, B cannot be used in computation. Because this is a phantom data, so therefore. That's why we use phantom data, both of time, like in both places. Now, main is there, and we are trying to, here F32 and F64 are hidden parameters. Phantom tuple type specified as character and F32. So A is character, this is F32, I guess. Yeah, exactly. Now we have a tuple one which is unused, therefore there's underscore. Now phantom tuple is like character and F32. A is a character, F32 is phantom data B. Now phantom tuple is something like Q, and then we are passing out phantom data, whatever we want to pass. And then we have a phantom tuple type specified as character F64 instead of 32. So we are doing the same thing, just the float size has increased or doubled. Then we have type specified as character and F32. We have a structure which is phantom structure, not phantom tuple, but phantom structure, which is again character and F32. So I think first one, which is A, is a character, and the second one, which is a phantom data, is F32. We are doing the same thing. Phantom structure, first is Q, which is a sort of character. Then for phantom, we are passing phantom data, which is whatever data, but is of type F32, float 32. It is of type float 32. All right. Now there is a structure 2 doing the same thing, just the size of float increased from 32 to 64. And our drama is over here, which will give us a compile time error. So let's see. First of all, just run it as it is. So it will give us no output. Then, yeah, give us no output. Now try printing this statement first. It gives us an error which is mismatched type. It says tuple, which is tuple2, expected a phantom type, phantom tuple with character and F32, but found a phantom tuple with character and F64. Yeah, because of tuple2. So tuple1 equals to tuple2. No, because of F64. How about we change it to F32? No errors then. Yeah, so tuple1 now equal to tuple2 yields true. So this is now true because of this F32, F64. Now same for here also. And since the type was different, so we get a compile time error instead of runtime error. That's better. It again says the same damn thing, which is F32 and F64. We'll just change this to F64 now. We can do anything. And this will give us without any errors. Yeah, as expected. Now, shall we move on? I guess so. So we will move on to a last topic of the day, which is test case unit clarification. So a useful method for unit conversion can be examined by implementing add with a phantom type parameter. Now the add trait is examined below. So this construction would impose self plus RHS is equals to output. So whether RHS defaults to the self is not specified in the implementation. Now there is a public trait which is sort of add, and inside that we are passing RHS, which is equals to self. Then there is a type output because we are not defining output over here. All right. And there's a function add which takes the self and then RHS, which is RHS, and then we give it a return of self dot output. Sorry, self colon output, which is the type output. Then we have an implementation u for add or for t of u. Why t? Because RHS, we don't know. We made it generic, so it can be anything. As for add, what it does, it has some sort of implementation. We'll not see it over here because this was just an example. Now this is the whole implementation. Do we have a drama? We do have a drama. So let's do that. And first of all, let's see what it's doing. We are importing from standard operations add. We are importing standard marker phantom data. Well, using and importing is the same thing, I guess. Either we use our own code or we use someone else's, but yeah, you're using the code only. That's what matters. Then we say derive, debug, clone, copy. So everything for enum inch, and then for enum mm, which is millimeter, we have everything, derive, debug, clone, copy, everything. Now it creates a void enumeration to define unit types. All right. Now the length is a type of phantom type parameter unit and is not generic over the length t. Now that is F64. Now the F64 already implements the clone and copy trait. So whatever this is now, there is a structure length which has a generic unit. Then we pass F64, and in phantom data we pass out unit. And this also has a flag of derive, debug, copy, clone, everything. What we are trying to do, the length is a type with phantom data parameter like unit exactly, and is not generic over the length type. It is generic, no? This is generic, but it says is not generic over the length type, that is F64. Also, unit is not F64. Yeah, obviously, I guess it is a string. Sorry, not, it is a structure. Unit is a structure. Why are we not creating something like enum unit inside that we pass something like inch and mm? Why are we not doing that? Why do we have to create two enums like inch and mm? Let's see what we are trying to do. And for the implementation of unit, we are saying add. So implementation of add for generic unit for the length, and then we are passing the unit to it. And we say type output is length unit, and we are defining the method add for the add. We are saying self, and RHS is given. RHS is length unit, length of the unit. And we say length of unit is, we return length of unit. Then we say length, we call length, where's the length? Yeah, this one. And we give it a cell.0, what is cell.0? So cell.0 is, the value, and then RHS.0, whatever the RHS.0 is, and then phantom data. And we are adding cell.0 plus RHS.0, and phantom data is the unit. We are giving it a unit. Oh, damn. Now in main function, we are seeing something like 1 foot is equals to length, which is in inches. We are passing length, which is 12, and the phantom data, which is inch. For 1 meter, we are saying the length is in millimeter. We are passing 1000 millimeter, and then we are passing phantom data, which is millimeter. Then the 2 feet, which is 1 foot plus 1 foot. For 2 feet, we are saying 1 foot plus 1 foot. All right, this 1 foot is used 2 times. I don't know why don't we multiply it, but all right. Because for 3 foot, we have to say 1 foot plus 1 foot plus 1 foot 3 times. Now the 2 meter, which is 1 meter plus 1 meter, is something like this. All right. Then we try to print 2 feet and whatever the value is, so dot 0. And then for 2 meters, we are again doing the same thing. And we are using a debug sort of display because we are not implemented our own display. So yeah, we see 1 foot plus 1 foot is equals to 2 feet, and the value of it is 24. And the inches is something we have defined. But if we just printed the 2 feet without, 0, then what? Sorry. I think we should see some inches and all that. Ah, shit. We saw inches, but it is with phantom data playground inches. So yeah, something we expected, but not this way. And then 1 meter is 2 meter, and the whatever the 2 meter is, which is 2000 meter, the mm. Find the unit over here. Now the nonsensical operation fails as they should be. Compile time errors, which is type mismatch. Like if 1 feet is there, which is like foot and meter or something like that, and we try doing like 1 foot plus 1 meter. Since the unit mismatches, so type mismatch, and we see a damn error, which we should, you know, 1 foot plus 1 meter expected something like length in inch, but we found length in millimeters. So it says two different things. All right. So I think we can move on. Oh, we finished. Sorry. Yeah, we finished. And now we are at scoping rules. And scoping rule is not a short topic. So, damn, lifetime. All right. So what is scoping rule? We'll see it tomorrow, but let's go through it. Like scope plays an important part in ownership, borrowing, and lifetime. Now that is they indicate to the compiler when borrows are valid, when resources can be freed, and when variable can be created, when variables are created or destroyed. Then there's RAII, which is variable interest to more than just hold data. RAII is resource acquisition is initialization. I don't know what that is. But resource acquisition, I think when we are freeing something, we are acquiring our resources, which is a memory. And that is also sort of initializing it back again. So when wherever an object goes out of scope, its destructor is called, and it is own resources are freed. Its own resources are freed. Yeah. And then there. Oh shit. What is this? We can do this and then we'll get this output. Why? Why? What is this? RAII and Valgrind. So Valgrind is something. Oh, oh, it is sort of test, I guess, for memory leaks and all that. I think I've used it in C also. That's what I remember. Valgrind is something we've used it. So if I say Valgrind and whatever we have a compiled val, I think I do not have a Valgrind. And first of all, Valgrind is not found. Let's say Valgrind and 30, 13. First of all, Valgrind is not found. So how about we install it? All right, we'll install it and then we'll call it and all that. So we'll prepare for tomorrow. We are installing Valgrind right now already. We are installing Valgrind and I want to see a Valgrind output right now. So if I just say Valgrind and 13, all right, 13.rs, not rs, but 13 output. And we see the same thing. Memory checking, and it is checking memory. Oh, how long does it take? Is it done? Is it not? I do not know. How about we copy that code? I have to quit it. Damn, it is stuck. So I learned something about Valgrind and all that. I think it is not done. It will be executed. So we'll see all these Valgrind and all that tomorrow. So I think I'll stop it. Bye bye. All right. Aye, aye, aye. Yeah. Is there some memory leak, I guess? No, there's no memory leak, so everything works. Valgrind, do something.